Hi, this is Jogadam. In this video, I want to show you how to make three-phase fault analysis using MATLAB simulink. This video is very helpful for MTECH, BTECH students of EEE, EE and ETC branches. And this is a very simple video to make your one model for BTECH and MTECH thesis. So let us start. First open your MATLAB file and go to Simulink library. From Simulink library, you go to Sim Power System. So this is your Sim Power System and open Specialized Technology, and from Specialized Technology you just open the elements, and from elements you just copy three-phase pi section line and add to new model, and then copy the connecting port. So now first we will make one subsystem. Now you can learn how to make a subsystem using MATLAB simulink. So first you check the max parameter. So this is 60 Hz. You make it 50 Hz. That is Indian standard frequency. Then you make it 30 kilometer and OK. And now you just make 5 section. Now connect all the sections. So all 5 sections are connected. Now you connect the connection port. So this is your port number 1. Then you change this port to port number 3 and make it left. So next you just here you can also change, this is port number 3 and here port number 1. This is your, also you change this to port number 3. Okay. Then you make it port number 6. This is also make it left. So make it port number 3. So now you connect this to output. So you connect now output port. First you click this block. So now you can connect the output port. So this is your output port, and you make it port number 2, port number 2, and okay. Then also you can change this port to 2. Then you make it 2 and make it port number 4. Okay, and this you make it port number 5. Okay, so this is your port number 1, 3, 6. You align the port like this, and this is your 2, 4, 5. Now you can make it a subsystem. That is, first you select all. After that, you um, make it subsystem. That is control G. Then delete this. So now we can make two subsystems like this. So already I have made two subsystem that is stored in my one library. So I can copy the two subsystem, then you paste here. Similarly, you can copy another subsystem and paste here. So now we can delete this. So now you learn how to make a subsystem using MATLAB simulink. Now let us collect our required blocks from simulink library. First you collect the three-phase fault, then you go to measurements and copy three-phase VI measurement, then you go to electrical sources and copy three-phase source, then you go to commonly used blocks, copy the scope block, then you copy the from block, you copy there, then to workspace, to workspace, and now all the blocks are connected, sorry, all the blocks are collected. So now we'll start the modeling. So another block is required, that is your power GUI block. Go to Simulink library and go to Sim Power System, that is specialized technology, and copy the power GUI block. So now all the blocks are copied. Now we'll start the modeling. First you connect your three-phase source. So we'll check the parameter. So this is your, we'll make it 500 kilovolt, that is phase to phase RMS voltage, that is 500 kilovolt. Then this is phase angle, degree 0, frequency. You can make it Indian standard frequency, that is 50 Hz. Internal connection YG, that is ground, and you just deselect this. Source resistance is this much, source inductance this much, and base voltage you make it, change it to 500 kilo. Then just take it, load for swing. Okay. Then after that you connect the three phase VI measurement. So now you connect this. Then go to max parameter and change this to phase, use label, then VABC voltage in PU, then current measurement, use label IABC, then current in PU. This is your 500 kilo nominal voltage used for PU measurement. Then you make it okay. So this name you can change here, that is your relay bus. You can change this to relay bus. Relay bus 1. So now you connect this to another subsystem, that is your subsystem 2, and you take another VI measurement or relay bus 2. Then here you change the max parameter, that is make it no, and this is also no. Okay. Then you connect the fault block here, A to A, B to B, then C to C. So after this you take another three-phase source and flip this block, then you connect this and just check the parameter. So This you make minus 30 degree and frequency is 50 Hz. This is your source inductance base voltage, then okay, and change this to 3 phase load. 3 phase load. This is your 3 phase load. Then you just set the power GUI, check the max parameter. It is continuous, make it discrete, and you check this to 3 into e to the power minus 5. Okay, then you connect this. This is your make it changes from this you make I A B C. So I A B C. Okay, then you write here okay, then to workspace. This is your variable name I A B C. Information decimation, then deselect this, then you check it to 0. This is your time series. Okay, then this is for IABC, then you just make another model for BABC and just make here this will change the BABC. BABC. Okay, then you connect these to scope 1 and here you change this to BABC and also you make it 0 and deselect this. Okay. Then so now you can connect this to workspace. So now our model is ready. Just now we will check the fault block parameter. So this is your initial status 0. Then we can find out the fault between phase A, phase B, phase C and ground. And during the fault analysis we have to choose the fault resistance, that is 0.001, or that should be chosen very small, and ground resistance also very small. So during no fault, this fault resistance is become very high, and this is okay. So now let's choose the model configuration parameter. So now you just make it ODE 23 TB and variable state. Okay. Then you simulate for 0.5 seconds. So let us check just parameters. Max parameter false. This is 500. Phase to phase RMS voltage 500. Phase angle 0. Frequency 50 Hz. And this is also it is correct. And this is you can check here the block parameter, that is already we have checked up it. Then now this you can also check. This is phase to phase, yes. Then this is 500. Okay. Now so now let us start so now let us start the simulation. Now first we can find out the there will be, if there will be no fault, then we can find out the phase A, phase B, phase C signal. So we have to deselect phase A, phase B, phase C and ground. Then OK. Then now you can run the model. So let us see the result. Just simulate the result. So this is the result. If there will be no fault, then this is VABC and IABC. So let us activate the fault. So first we activate the three-phase fault A, B, C. So let us see the result. So this is the three-phase fault. If there is a fault occurs in three-phase, this is the signal. So let us see the fault between phase A, phase B, phase C and ground. So this is the fault phase A, phase B, phase C and ground. Then now we can see the fault between phase A and ground, that is any phase and ground. Let us see. So this is the fault between phase A and ground. So now we can see the different 3D views. So this is the mesh view or three-dimensional figure for the fault between phase A and the ground. You can see here the sharp view, and this is the sharp view. And you can see also contour. This is the contour for fault between phase A and ground. You can also see the different views, that is ribbon. This is the ribbon. And there were so many views we can find out. This is the stem view, and now we can analyze this fault by wavelet analysis method. See the CWT. See the approximation. Then let us see. For a no fault view, so let us assume that there will be no fault. So let us see, if there is no fault, then look at this. Now we can analyze this signal by reflector analysis. So this is the view. There is no fault occurs. So this is the approximation pattern. Similarly, we can do the SWT. With the SWT decompose signal. Okay. Decompose signal. Okay, there is some problem. So thank you very much for watching my video.